Hi, everyone. I'm Ellen from Veza, the authorization platform for data security. Thanks so much for joining us today. I'm excited to welcome you to our journey through the history of hacks. We'll be giving a high-level overview of the techniques behind some of the biggest hacks and data breaches in history, and what we can learn about protecting ourselves. At Veza, we believe that while the tools and strategies employed by attackers are constantly evolving, there's one form of defense that almost always works, and that's least privilege. On today's episode, I'm joined by Kale, a product marketer here at Veza, to talk about server-side request forgery of SSRF attacks on AWS. Hey, Kale, take it away.
Hi, Ellen. Yes, SSRF is a common hacking technique where an attacker tricks a server into accessing resources on their behalf to help them gain access to data or control of other systems. In the context of AWS, this particular technique was used as part of the infamous Capital One hack of 2019. Now, that breach encompassed about 100 million consumer applications for credit. It leaked 100,000 social security numbers, 80,000 linked bank account numbers. It was one of the biggest financial breaches ever. And it all hinged on a single EC2 instance, a virtual server on AWS, running a simple web application firewall. Here's how it works. Each EC2 instance, it's here, has direct access to a metadata service that, among other things, validates the roles that the instance is allowed to assume. And those roles governs the permissions that it has, for example, to read or write to storage buckets on AWS. So the meta service then returns temporary credentials to the EC2 instance, and it uses them to interact with other services and resources on AWS. So without going into too many details here, the Capital One hacker was able to trick that EC2 instance into relaying their requests on to the metadata service, and that allowed them to list all the roles the EC2 instance has access to and get those temporary credentials. And then using those credentials, they can access absolutely any resource that the EC2 instance can. In this case, they stole a whole bunch of data from S3 buckets that contained sensitive data information, customer information.
Wow. Okay. Thank you for explaining that. So now that we understand how this kind of attack works, how would you suggest that we stop it?
Yeah, absolutely. So there are two basic approaches here. One that is always different and one that stays the same regardless of what type of attack you're dealing with. So the first approach is improving the security architecture. And, indeed, in the last 4 years since the Capital One hack, this particular type of attack has gotten much harder to pull off. There's been changes to how that metadata service works that makes it harder for an external actor to get access to the credentials in the first place. And there's also been improvements in how we actually validate credentialed requests so that we can detect and stop server-side request forgeries. Now, that's all great, but you know that hackers are always looking for the next vulnerability, right? So another way that we could approach a topic like this is to ask, hey, how come a basic firewall application needed access to all that customer data anyway, right? The damage from this attack was so huge because the compromised EC2 instance had so much access. So we should be asking, how do we make sure that these machine identities like EC2 instances don't have all the keys to the kingdom?
You're absolutely right. That is the right question. Can you show us how Veza can help with this?
Sure thing. So let's have a quick look into the Veza dashboard. I have a dashboard here that tracks misconfiguration and risk across my databases, my SaaS apps, and in particular here, we're talking about my cloud infrastructure, right? One thing that we can track is identities and roles that have a high blast radius. And that's, what we call, identities with access to a large number of resources. This is a strong warning sign that we have overprivileged identities we should review. And more specifically, we can look at privileged access by machine identities, and that can include EC2 instances. So to dive into this particular report, what we mean by privileged access, we're showing a few specific things here. And one is actually this permission to list buckets and read all bucket objects. So this is the exact permission that allowed the Capital One attack to happen, along with some other risk factors like access to roles that grant admin permissions. Now, another thing that we can do is build a specific query that looks at AWS roles with a high blast radius. So jumping into the query builder here, I've set up this query to connect IAM roles with a specific subset of resources on AWS. I've included Lambda functions, EC2 instances, S3 buckets, and database tables. And I'm showing only those roles that have access to at least 20 different resources. So that's a way of a proxy for getting to that high blast radius we're talking about. So we have identities that can access a lot of different things. And you can see that this actually includes two of our EC2 instances here, the roles that our instances use, rather. If I open this up further, I can actually see exactly what these permissions are. I can actually see exactly what functions, what buckets, what tables each of these roles is able to access. And I'll note here, one of the ways that highly permissioned roles come about is that a highly permissioned role can get nested inside a second role, and then that's what's granted to an identity. That means somebody that's looking at what roles an identity has, they might really have to dig in to understand the full access that an identity has. So this little icon here, if I zoom in a little bit more, actually indicates a role that has other roles nested inside of it. And we actually show that precise relationship here. So this is something, again, that when you see, you want to investigate and make sure that you understand access. So once I've set up a query like this, I can set up automated alerts so that my ops teams can always know if a new high blast radius account crops up. They can investigate and remediate as necessary. So I can't always predict how an attacker is going to be able to access my system or what the door is going to be. But by automating permission monitoring like this, I can make it much less likely that a compromised identity leads to a big breach.
That makes sense, Kale. Thank you for explaining all of that. And thank you to everyone for joining. We'll be back soon to talk about other hacking techniques that have led to big data breaches. But what we've learned here today is that while hackers can always find new gaps and security flaws, sooner or later, almost all hacks rely on a compromised identity. That means that applying least privilege will always make you safer. See you next time.
Thanks.